Alright, welcome back to part 2 of lesson 6-6. In this part of the series, we are going to focus on correlation. One main reason that we can create scatter plots is to show correlation between two variables. A correlation is a relationship between two variables. That's going to be an important vocabulary word when we're discussing lines of best fit and scatter plots. Now, we can classify correlations in a variety of ways. The first way we're going to look at is going to refer to the direction that these correlations are showing. So if we have a positive correlation, that means as the value of one set of data increases, the other data will also increase. In other words, we have a positive slope or a positive rate of change. An example of this would be the amount of rain that we would have a positive correlation with the size of the puddles. The more it rains, the bigger your puddles are going to be. A positive correlation would be going in a positive direction, something similar to this. We also have a negative correlation, and negative correlation means as the value of one set increases, the other will decrease. So an example of a negative correlation would be the age of a watch and its battery energy. The longer you have a watch and the longer that you use it, the less and less energy is stored in that watch as the battery starts to die. Alright, when we have a negative correlation, it's going to be a correlation that has a negative slope or a negative rate of change that is going downhill. Now, sometimes we have a relationship that might not show any correlation at all. If we have no correlation or no relation between the variables, we say that these data sets have no correlation. An example of this could be the temperature in Alaska in your grade in math class. What the temperature is currently in Alaska really has nothing to do with what you're scoring on your mastery checks or your tests. So we would say that those have no correlation. To just kind of give you a visual example of each again, we have an outline here of a positive correlation, a negative correlation, and no correlation in relation to a scatter plot. So in our positive correlation, we have time spent studying and students' grades. The longer that you study, the more likely it is that your grade is going to be higher. There's a relationship that's shown between those. Now, obviously, there's some variation within there. Just because you study the same amount of time doesn't mean that everybody is going to score the same that has studied that time. For example, if we look at these dots right here, those are all pretty much spent about the same time studying, but we do have different grades. But it does give us a trend that we can use to kind of help project and predict to future values. We also have an illustration of a negative correlation here. This one refers to the amount of time spent training and the time to run a 100-meter dash. Obviously, the more you train, the more in shape you're going to be, so it's going to have a negative correlation on the time it takes you to actually run it. You're going to run it faster when you have more training. And then we also have another example over here that is no correlation, and our X values on here are referring to shoe sizes, and our Y's are referring to colors in the rainbow. So what shoe size you wear does not really have any effect on how many colors are going to be in a rainbow. Alright, so scatter plots can help us see correlation between bivariate data. However, this does not mean that one causes the other. If we don't get across anything else to you in this lesson, remember, correlation does not equal causation. Just because two things are correlated does not mean that one thing necessarily causes the other. There are always other variables to take into account. For example, if you're thinking about the amount of time you study for a test, it would have a positive correlation with your test grade. Obviously, the more you study, the better you're going to do. However, the study time alone is not what decides your test score. There are a lot of other factors, a plethora of other factors that could affect your test score. Maybe you got a bad night's sleep the night before. Maybe you got a good night's sleep. Maybe you ate breakfast. Maybe you didn't. Maybe you had a cold that day and weren't feeling your best. So there's all kinds of other things that could have an influence on the data. Just because the time you spent studying does have a positive effect on your test grade, it's not going to be the only thing that determines it. So we say it correlates, it does not cause. And just kind of another funny example for you guys, this is based off of real data. The chart below shows that there is a correlation between per capita cheese consumption and the number of people who died becoming tangled in their bed sheets. You can see that the two match pretty well along, but there's going to be very few people that are going to make the argument that eating cheese is going to cause a rise in death by bedsheet. So just kind of a funny example there for you guys. All right, in addition to classifying correlation as positive, negative, or no correlation based on its direction, we can also classify correlations as strong or weak. The closer the relationship between the two variables, the stronger the correlation is going to be. Now, the strength of a correlation is given on a scale from -1 to +1, and we call this value the correlation coefficient, and we use the letter R to represent it, or the variable R. Now, the stronger the correlation, the closer the absolute value will be to 1. So if we have something that's like 0.9, 0.95, it's going to be a very strong correlation. But also if we have something that's going to be -9.5 or -9.8 that's close to -1, that's also going to be a strong correlation. We tell whether it is going to be a +1 or a -1 based on the direction of the correlation, whether we establish if it's a positive correlation or a negative correlation. Alright, so just like the stronger correlation, we also have weaker correlations. And the weaker the correlation, the closer the absolute value of the correlation coefficient will be to 0. So we'd be looking at things like 0.2, 0.3, -0.2, -0.05. The closer that those values are to 0, the weaker it's going to be. And if the relationship has no correlation, the correlation coefficient will be 0. That's one of those situations where we can't really tell what's going on. We don't know if we're going positive. We don't know if we're going negative. All we can say is that there's no correlation. Now, unless we are using computers or calculators, we do have to estimate the correlation coefficient. Now, I'm going to jump down to another slide that's going to have a good visual representation that kind of shows the scale that we use to help us make our estimations. So looking at this chart, we are going from a perfect positive correlation with a correlation coefficient of 1 to a perfect negative correlation of -1. Now you can see for the perfect correlations, these make almost an exact perfect line. If we were to draw a line through these, we would be able to go through every single dot if I could draw a straight line. The same with the perfect negative correlation. Now we also have ones that are not perfect but are still high. As you can see here with our 0.8 and our -0.8, the dots are still pretty close to a straight line, but they're not going to fall exactly on the same line. We have a couple that went a little bit to the left, a couple that went a little bit to the right, but overall we can still draw a pretty good line that hits a lot of the points. Now notice the weaker we get, the more spread out it is, and the harder it is to draw a line that is really close to all the points. So a low positive correlation or a low negative correlation is going to be a value that's closer to the 0.3 or the -0.3. And if we have absolutely no correlation at all, we can't draw a line going up, we can't draw a line going down, we would say it has no correlation. So again, this is an estimate, so your estimates might be a little bit different from your neighbors. They might even be a little bit different from the key when you check your answers. But use this kind of as a guide to give you some milepost markers as to help you decide what correlation coefficient you should use. Alright, so again, this is going to conclude this part of the video series. Your practice is immediately below. Go ahead and give that a try, and then when you have completed that practice, come back and we'll conclude with part 3. Alright, see you guys there.